this is the video for slope of a line. You can read the definitions here. I'm just going to quickly talk about a couple things and then do the examples. So, slope of a line is your ratio of vertical change, your rise, to the ratio, or to the horizontal change, the run. This is the formula. If you have 2 points, you can use this formula where x1 and x2 aren't the same, because if they're the same, you're dividing by 0, which would give you undefined slope, so that'd be a vertical line. So parallel lines have the same slope. Perpendicular lines have negative reciprocals for the slope. And then, like I said, you can read these definitions. And I will mention different forms of lines as we do some problems. And then this activity, you don't have to do this, but it is a pretty cool activity if you have students that, like if you have like after the SOLs or something, you got time to kill. It's a fun activity for them to do for the stairs to see if they're up to code. I thought it was kind of interesting. For your examples, these are already have the answers here, but I was going to talk you through them. So we want to determine if the lines are parallel, perpendicular, or neither. So so you have different forms of the line. You have point slope form, slope intercept form. And so what I would always suggest you do is if you're trying to compare slopes, the easiest thing to do, so I mentioned on here, standard form is useful when you're finding the intercepts. Point slope form is when you have the slope and a point on the line to do. Slope intercept form is the easiest one usually to use to compare the slopes to determine if they're parallel, perpendicular, or neither. It's also the easiest one usually to graph. So usually I always write everything in slope intercept form, y equals mx plus b. So m is your slope and your b is your y-intercept. So what I always do for problems like these is I solve both equations for y and then I compare the slopes. So to solve the first equation for y, I need to subtract my 2x over. So I'm going to have negative 5y is equal to negative 2x plus 7. For the second equation, let me just finish the first one. And then what I do is now I have my y on one side and I've got x and my number on the other side. So now I need to divide by negative 5 to get y by itself. And when you do that, you have to make sure you divide this piece by negative 5 and this piece by negative 5. So some people would probably write, let me do it up here at the top. Some people would probably write negative 2x plus 7 divided by negative 5, which is fine, but we want the slope and the y-intercept. So what you want to do is do it by pieces. So you want to divide this by negative 5, this by negative 5, and this by negative 5. So these cancel, so you're left with y is equal to negative 2 divided by negative 5 becomes positive 2/5 x, and then 7 divided by negative 5 is negative 7/5. So there's that one in slope-intercept form, y equals mx plus b. And then to do the second one, I would need to add 5 to both sides. So I have 15y is equal to 6x plus 5. And then my last step would be to divide by 15. And again, instead of writing it as 1, you want each piece because you need the slope. Okay, so 15 cancel here. We get y is equal to 6 divided by 15 reduces. If you take out a 3, this would be 2, and this would be 5. 15 divided by 3 is 5, so I'd have 2/5 x. Whoops, I could write 2/5 x. And then 5 divided by 15 reduces, I can take out a 5, so I'd have 1/3. So for this one, for this first one, I have my slope is 2/5, and my y-intercept is negative 7/5. And for the second one, my slope is also 2/5. And my y-intercept is 1/3. So they have the same slope and a different y-intercept, which makes them parallel. So these are parallel lines. So it's important to note what the y-intercept is, because if they're the same y-intercept, then it's the same line. They're not parallel lines, it's the same line. So that's why I always write down what my y-intercept is as well. So same slope, different y-intercepts, they're parallel. Okay, for the next one, again, we want to solve and get it into y equals mx plus b, the slope-intercept form. So the second one's already done for us, other than you can flip it around if you want. But to solve the first one, I'm going to subtract x. So I have negative 3y is equal to negative x plus 4. And then I'm going to divide by negative 3. And again, I'm going to do each piece. So negative divided by negative is a positive. So I'm going to have y is equal to positive 1/3 x. And then 4 divided by negative 3 is minus 4/3, because these ones cancel. And then the second one is already solved. All I would do is, to make it look like y equals mx plus b, I would turn it around. But you don't necessarily have to, but I usually do. So for my first line, my slope is 1/3 and my y-intercept is negative 4/3. For my second line, my slope is negative 3 and my y-intercept is 1. So for this one, the slopes are not the same, which means either they have to be perpendicular or it's neither. So in order for them to be perpendicular, they have to be opposite signs. So they are. One's 1/3 and one's 3, and they have to be reciprocals. So if I flip 1/3 over, I get 3, or if I flip 3 over, I get 1/3. So they are negative reciprocals, meaning they're opposite signs and they're reciprocals. So these lines are perpendicular. Okay, for this last one like this, we have 4x plus 2y equals 6 and 12x minus 6y equals 6. So I'm going to solve both for y again, get slope-intercept form. So I'm going to subtract 4x. So I get 2y equals negative 4x plus 6. And then I divide everything by 2. So we get y equals negative 4 divided by 2 is negative 2. So negative 2x plus 6 divided by 2 is 3. And then for the second line, I'm going to subtract 12x. So I've got negative 6y is equal to negative 12x plus 6. And then I'm going to divide everything by negative 6. And I'm going to get these cancel, so I get y is equal to negative 12 divided by negative 6 is 2. And 6 divided by negative 6 is negative 1. So for this one, my first line slope is negative 2. Y-intercept is 3. For the second one, my slope is 2, and my y-intercept is negative 1. So these are not the same, which means they can't be parallel. These are opposites, okay? So it's either perpendicular or neither. They're opposite signs. However, they are not reciprocals, because I would have to have one of them be either negative 1/2 or 1/2. So if I flip them, I would have 1/2. So they are not the same, and they are not negative reciprocals, meaning these lines are neither one. They're neither parallel nor perpendicular. Okay, so if you have to determine if lines are parallel, perpendicular, or neither, slope-intercept form is usually the easiest way to do that, so you can compare the slopes and the y-intercept. Okay, the next part wants you to use the formula for the slope of a line. Let me show you on the computer screen. I'm not going to write all this. To solve the problem. So you've got Justin is driving from home to his college dormitory. At 4 p.m. he is 260 miles from home. At 7 p.m. he is 455 miles from home. Graph the line that represents Justin's distance from home at a given time and find and interpret the slope of the line. Okay, so we have at 4 p.m. Let me just do, this is example 2A. Okay, so at 4 p.m. he is 260 miles from home. At 7 p.m. he is 455 miles from home. okay? So, because he's going from home to his college dormitory. So he's 260 miles from home and then 455 miles from home, getting closer to his dormitory. So graph this line. So our points that we're going to use are 4 and 260 and 7 and 455. Now, when you have to draw these graphs, you don't have to, I can't draw all that well, so you don't have to worry too much about it. As long as your numbers are correct and it looks remotely correct, that's fine. So to graph, I'm just going to graph these 2 points. Now you can find the equation of the line and graph if you want to do that. It's easy just to plot 2 points and connect them with a line as well. So I'm going to go that way. I will talk about how to find the equation of the lines should you want to do that. So for us, we've got 4 p.m. and 7 p.m. So I'm going to put time on my horizontal scale here. So I got 0, and then we got 2, 4, 6, 8. So this is my time. And then here I've got to go from 260 miles to 455 miles. So I'm going to go, let's see, this will be 200. So 200, 400, 600, so this would be 500, 300, 100, okay? So there is, so this I'll put miles. I didn't label it on the document. I should have. This would be time. But anyways, so I've got the points 4, 260. So at 4 o'clock, he's 260 miles from home. So he's between 200 and 300, roughly there somewhere. And then at 7, he is 455 miles from home. So 1, 2, do these little tick marks. So here's 7 and 455 miles. So he's between 4 and 5 here. About maybe right there, I guess. So at 0 time, he's 0 miles from home, right? So you start out at 0. So there's our line. So this is the point 7, 455, and this is the point 4, 260. Okay, so there's my graph. So it says to find the slope, find and interpret the slope of the line. So here I'm going to find my slope. So I'm going to use my slope formula, which is y2 minus y1 over x2 minus x1. So I take my difference in my y's. So I'm going to do 455 minus 260 over the difference in my x's. And whatever I've called y2, I have to use that point to start with for x2. So 7 minus 4. So that's going to be equal to 195 divided by 3, which is equal to 65. So if your slope is 65, that is a rate of change. You are changing by a rate of 65, which means he is driving 65 miles per hour, which would be, on average. So he is traveling 65 miles per hour. So that's the interpretation of the slope, because it is a rate of change. So at 4 o'clock he was 260 miles from home. At 7 o'clock he was 455 miles from home, so he's traveling 65 miles per hour. Now you can also find the equation of the line and use it if you wanted to, and so I've done that on the notes. Just to show you one, point slope form, you pick a point, whatever point you want to use, and your point slope form is y minus y1 is equal to m times x minus x1. So you still have to solve for the slope first, so I would have to do this first anyways. I would have to use my slope formula and do this. So I know m's 65, so I would have y minus, pick a point. So I'm going to use 4, 260. So if I use the point 4, 260, I've got y minus 260. My y value is equal to my slope, 65, times x minus my x value, 4. And then I solve this equation. So I've got y minus 260 is equal to 65x minus 260. And then I add 260 to both sides. And so when I do that, this cancels out. So I get y is equal to 65x. Which means my y-intercept, my slope is 65, which we already knew, and my y-intercept is 0, which I also already knew because I said at 0 time, you're 0 miles away. So there's your equation of the lawn. Again, assuming he's traveling at a linear speed at a, it's not changing or anything, which normally when you drive, your miles per hour would go up and down, but we're going to assume it's a line. So he's going 65 miles per hour. And if you use the other point, the 7,455, you could also use the 0.00 too, but just using the ones they gave you, 7,455, you would get the same thing. So if I use this point to do point slope form here, I would do my y minus my y value. It's equal to my slope, which I've already done the slope formula here, times x minus my x value. Solve that one. Y minus 455 is equal to 65x minus 455. Add 455 to both sides. They all cancel. I get y is equal to 65x again. So anytime you use point slope form, you pick a point and do it. You don't have to do it both ways, but should you do it both ways, you should get the same answer because it's the same line. Okay, so you really, truthfully though, you didn't need all this. I just wanted to show you point slope form. You could have stopped there. Okay, and then I think there is maybe one more, or no, two more. So part B here, it says, for example 2, it says, again, I'll show you the things that I haven't to write it all. Todd had 5 gallons of gasoline in his motorbike. After driving 100 miles, he had 3 gallons left. The graph below shows Todd's situation, so it gives you the graph below. Find the slope of the line, and what does the slope tell us, and what is Todd's miles per gallon. So it gives us this graph here. So it shows you at 5, that's where you start at. He had at time 0, he had 5 gallons of gasoline. And then after driving 100 miles, he had 3 gallons of gasoline. So this is the gas in the tank. So our slope is the rise over the run. So we're going to do rise over run. So it goes down 2 and then over 100. So your rise goes down, which means it's negative, and then you go all the way over to 100. Okay, so that's our slope, and that's based off that graph there. So we went down 2 over 100, which means you can reduce that to -1 over 50. So that means if he's doing the miles traveled, let me just draw this so I don't have to go back and forth to the computer screen. So you've got 5, and we're down to 4, 3, 1, down to here, and then this is 50 miles traveled and 100 miles traveled. Whoops, 100. Okay. So you had the point 0, 5, whoops, and 103. Okay, so this was gas in the tank, and this is the miles traveled. So this means he is losing for every 50 miles. The miles is your run here. For every 50 miles, he's losing a gallon of gas. You can interpret it that way. He burns 1 gallon of gas. If you wanted to get into each individual mile, how much does he burn each mile, then you could say it's -0.02. So he would be burning 0.02 gallons of gasoline for every mile. I put that on the notes, but I don't actually think most people would think of it that way. I think most people would think of it, how many miles do you burn a gallon of gas? So he can travel 50 miles on 1 gallon of gas. That's what I think most people would do. However, you could divide it. It would be 0.02 gallons of gas for every mile if you really wanted to, but I think most of you would just think of it this way. So I think I'll just stop there. So he can drive 50 miles. For every 50 miles he drives, he burns 1 gallon of gas. And so that is his mile Oh, it actually says miles per, no, that would be right. Miles per gallon would be total 50 gallon for 50 miles per gallon. Okay, sorry. Sometimes talking to myself on video, I get confused. Okay, so for every 50 miles, he burns 1 gallon of gas. So you can kind of ignore the .02 stuff. I don't think most people think of it that way. I must have thought of it that way when I did it, but most of you would stop there. Okay, so for the last one, finally, we have the pitch of a roof. Here, let me show you this again. The pitch of a roof is the ratio of the rise to the half span. If a roof has a rise of 6 feet and a span of 30 feet, what is the pitch? And a half span would be half of the span, right? So if your span is 30 feet, half span would be 15 feet. So we want to know what's the pitch. So this is just basically the slope, right? So you've got your rise, you've got your run, the span is the whole thing. Your slope, because everybody knows the roof, it meets in the middle here, so your roof doesn't go, well, I guess on some houses it does, but for most houses here, you've got the pitch, which stops in the middle. So that's why it's half of your span, because your span's the whole thing. This is half of your span. Okay, so we have the roof has a rise of 6 feet and a span of 30 feet, which means that the half span if we do half of the span, oops, got ahead of myself and wrote 3 too fast. Half of 30 would be 15 feet. So the pitch of the roof is the ratio of the rise to the half span. So our pitch would be equal to our rise, which is 6, over our run, our half span, which is 15, which reduces to 2/5. So our pitch of that roof is 2/5. So that is all for slope. So if you have any questions, please send me a message. And again, sorry, I got to talking about the .02 here. I need to go back and delete that. I'll try to remember to do that. But most everybody would just think of it as for each gallon of gas you burn, you run 50 miles. So anyways, if you have any questions on slope, please send me a message.